Hello and welcome to a chemistry video on polymers for AQA chemistry. There's not too much to go through, it's just basically a knowledge topic, so I'm going to run through what you need to know. You have addition polymerization and condensation polymerization, which we're going to go through both. Now, for addition, it's going to involve carbon-carbon double bonds, so alkenes, which is why you will see names like polyalkene, stuff like this. That's a bracket. Now, for example, we can have, this is how you're going to have to draw it. R is denoting a group, so it can be hydrogen, CH3, a methyl group, anything like that. You need to make sure these bonds trail off of these square brackets. Now, in terms of reactivity, they are known as chemically inert. This is due to the non-polar nature of the CH bonds. Condensation polymerization. So polyesters. Now polyesters are made of dicarboxylic acids and dialcohol, so diol. Polyamides are made of dicarboxylic acids and as you probably guess, diamine. Because how we would make an amide is by carboxylic acid and an amine. So we use dicarboxylic acid and diamine. And that's why we can form these polymers, because they can combine to make chains. Yes, so if we use the carboxylic acid, we get a product of the amides, for example, here, and we get water. And we get water if we used here. It used this reaction to make the polyester. If we use a diacyl chloride, we would get HCl, in both reactions. We need an acid catalyst in the carboxylic acid reactions, plus it gives an equilibrium mixture, which you would know, which is why the more reactive acyl chloride is a bit better, because it will actually go to completion, doesn't require a catalyst. However, the issue with that is it's a dangerous element, because it will give off the HCl fumes. So here we have an example of combining. As we can see, we've got our diacyl chloride here with a diol, which we therefore know is going to make an ester. If we go up to the top here, our diol will make our ester, polyester really, I should have said, sorry. And so here, what it's going to form is this. And we have our carbon, our double bond, because it's going to effectively, just think of it as these breaking off, because this could be an OH in another case. In the carboxylic acid, you would remove that, so think of it as removing that. We get our CH2, 3, C double bond O, and it'll go to our O, because think of it as removing this. And then we have our benzene, and then our O, and you'd use that, and you put an N. And then it's 2N minus 1 X of your other product, so HCl in this case. Here's some information. I'm not going to read it out because you can do that yourself. These are some good notes to have. That's pretty much it. The best way to learn this stuff is through examination questions and just repetition.